reviewing the back side of quiz 1.1 to 1.3. Just went over the front, and we're gonna look at the back. Okay, so start by evaluating the piecewise function at the given values of the independent variable. Circle the answer for each. So first of all, piecewise functions. So the basic idea here is that f of x can either be defined as one of two things. F of x will either equal 4x minus 2 or it will equal 5x plus 4 under different conditions. Under the conditions wherein x is less than or equal to 3, we use f of x equals 4x minus 2. For values of x that are greater than 3, we say f of x equals 5x plus 4. And it's literally that simple. You should only plug into one of these, either the 4x minus 2 or the 5x plus 4, depending on the x value for which you're evaluating. So remember, the x value is represented by the thing inside the parentheses. So if I'm doing f of negative 2, that would mean that, I would go with x is less than 3, or less than or equal to 3, or greater than 3? Well, negative 2 is less than 3, so I'm going to use the top one. I'm just going to do 4x minus 2, but if x is not x, it's now negative 2. 4 times negative 2, minus 2, negative 8 minus 2, negative 10. Boom. F of negative 2 equals negative 10. Same thing for f of 6. Does f of 6 fit into x is less than or equal to 3 or x is greater than 3? Well, 6 is greater than 3, so we're going to use 5x plus 4 for this. So I'm just going to write 5x plus 4, but x is not x, it's now 6. So 5 times 6 plus 4, 30 plus 4, 34. This is not that complicated once you understand what's going on. All right, lastly, f of negative 3. Well, negative 3, it's not greater than 3. It's actually less than or equal to 3. So we're going to plug in this top one, 4x minus 2, just like we did for this first one over here. But x is now negative 3, so 4 times negative 3 minus 2, negative 12 minus 2, which is negative 14. Final answer, there we go. That is number 6. All right, lastly, we got some graphical analysis here. Or not quite lastly, but almost lastly. So graphical analysis, domain. Remember, we want to describe the domain in interval notation of this function. And domain, remember, describes over what x values does our function exist. Well, first thing I notice is that I've got an arrow right here. So that means I go left and down forever. So left and down forever. But this is just a dot, so that just stops right there. So as far as my x values are concerned, my leftmost x value is negative infinity, and my rightmost x value that I reach is positive 6. So I go from negative infinity to positive 6. Remember, I put parentheses on negative infinity, a bracket on 6, because 6 is an open circle right here at x equals 6. Notice how I did not refer to the y values at all. We do not need y values to answer this domain question. Secondly, range. Range of the function. So range is the exact opposite. Rather than looking at these x values, all we care about is the y. So we always put the bottommost first, topmost second, with a parentheses in between. Well, what's the bottommost y value that we reach? Well, this goes down forever. So the bottommost y value that this function reaches is negative infinity. The topmost y value, some of you might be tempted to say this, but there's a higher point that this reaches. Negative 3 would not be correct. The topmost y value would be positive 1. And a line acts as a closed circle, so bracket on 1, parentheses on negative infinity. All right, x-intercepts. They mean the same thing they did on the old video. X-intercepts, where we cross the x-axis, or where we intersect the x-axis. That's our x-axis. Intersection points negative 3 and 3. I'm just say x equals negative 3, comma 3. You could also write it as two coordinates, negative 3, 0, and 3, 0. Remember, this is a coordinate, not interval notation. Okay, which is why I didn't put a u here. I put a comma because these are two separate points, not two different intervals. Key distinction there. All right, y-intercepts. Y-intercepts, same thing as x, but with the y-axis. Y-intersection right there at 1. So we can just say y equals 1, or we can say coordinate 0, 1, as in x equals 0, y equals 1. Either one of those would be an acceptable answer. All right, so increasing. Apologize for the non-steady camera. All right, increasing. Increasing behavior, remember, increasing, decreasing, and constant. These three things describe over what x intervals is the graph going up, down, or neither, basically going straight to the right, constant, as we go left to right. So as we go left to right here, so this one starts infinitely down here. So as we go left to right, this one is going up, starting at an x value of negative infinity and stopping at an x value of negative 2 right there. So we're increasing from negative infinity to negative 2. We always use parentheses for all three of these. Negative infinity to negative 2. All right. Decreasing. Well, as we go left to right, here's constant. So we know we're constant from negative 2 to 2. Remember, x interval. So we're constant from negative 2 to 2. And then we are decreasing, starting at 2 and going until 6, from here to here. That's 2 to 6. Decreasing from 2 to 6. And there we go. All right, evaluate f of negative 2. Well, remember, what does this represent inside the parentheses here? That's an x value. So when it says to evaluate f of negative 2, and you know x is negative 2, it's asking you, when x is negative 2, what's y? So x is negative 2, y equals question mark. That's what this is asking right here. Well, at x equals negative 2 right here, the y value that corresponds there is 1. So the answer is 1. Okay, ordered pair of a relative minimum. All right, so these are extreme values, minimum and maximums. A minimum can either look like a valley, that would be a minimum, a relative minimum, or it can look like an endpoint, that would be a minimum, or that could be a minimum. Either one of those three could be minimums. We have one of those on this graph. It's right there. The coordinates of that point are 6, negative 3. Maxes could look like the exact opposite. Either a peak, doesn't have to be a rounded one, could be like sharp, like an absolute value or something. That'd be a max. This could be a max, or that point could be a max. Notice how they all are closed circles for endpoints. Open circles are never maxes or mins for endpoints. That's just a quick recap of maxes and mins. All right, lastly for the choice number 7, at what value of x does f of x equal negative 2? Well, it's kind of like the reverse of this question. This one gave us the x and asked us the y. This one gives us a y and asks us what's the x. So y is negative 2, what's x? Is what this is asking. So, well, when y is negative 2, that'd be down here. There's two places, one here, one there. The x values there are 5 and negative 5. So you could say plus or minus 5 if you're fancy, or you could say 5 and negative 5. Those would be the two values of x for which that's true. All right, let's tackle the domain. All right, so say the domain. When we are algebraically finding domain, there's two things that we need to be on the lookout for. The first thing is denominators with x's in them. The second thing is even powered roots with x's in them. Our steps for this are always to start by assuming the domain is all real numbers. So since this one has neither a denominator or a square root, this one here, we can just assume the domain is all real numbers. So you can just write this little all real numbers. That's the symbol that means that. You could also write all real numbers. Or you could say, in interval notation, negative infinity to infinity. any one of those three are all perfectly correct answers. Okay, for this one, anything with a denominator with an x in it. If you could think of a value for x that makes the denominator 0, then your domain is going to be all real numbers except for whatever that value was. So, for example, what makes x plus 5 equal to 0? Well, if I solve it, I get x equals -5. So I know my domain is all real numbers, x cannot equal -5. If you want to get fancy and put an interval notation, that would be -infinity to -5, union -5 to infinity. That includes everything except -5. All right, lastly, when you're dealing with even-powered roots, so like a square root or a fourth root, basically what creates problems here for domain is anything that would force you to take the square root of a negative number. So essentially, for our domain, we want to keep whatever's inside of that radical positive or 0. So we set it to be greater than or equal to 0. And then if I solve this inequality, I'll get my domain. So plus 3, 3x is greater than or equal to 3, divide by 3, x is greater than or equal to 1. That is one correct version of your domain. X is greater than or equal to 1. Now, interval notation for that would be 1 to infinity, like so. Either one of those would be correct. Please ignore my stray mark right there. That's x is greater than or equal to 1. That concludes the video on the 1.1 to 1.3 quiz.